Welcome, everybody. I'm Matt Burrough, and this is Insider Master Key Attacks, Real World Escalation Privilege. I'm Matt Burrough. You can find me on Twitter at Matt Burrough. So, little bio real quick. Who's Matt? I'm Matt. I'm a corporate penetration tester and red teamer. So I do insider attacks on a large corporation, trying to find vulnerabilities and get them fixed before real attackers can, and also helping the blue team improve their detections. Aside from that, I'm also a Locksport hobbyist, so I've been a member of TOOOL for quite a few years now. I travel internationally to the Dutch Open, the lockpicking competition in the Netherlands every year. It's a lot. Also the author of the book Pentesting Azure Applications. So if you're interested in cloud security stuff, you can go look that up. It's from No Starch Press. All right. So before we get into some of the attacks, I want to go over how master keys work really briefly. This is not a complete overview of master keying systems. There's a lot of really smart folks who know a lot about master keying. I only know enough to be dangerous when it comes to pen testing, but this is enough of a primer to get you started. And I want to thank Deviant for a lot of these intro slides. He has a really good collection of diagrams for how locks work, and so instead of recreating the wheel, I've borrowed from him with his permission. So thank you, Deviant. So anyone who's been around locks for a while and has done a lot of Locksport work has probably seen this diagram and has understands what we're looking at here. But just in case, this is a cross section of a lock. You can see the plug in the center there in gold. This is the part that spins when you put in a key and turn the lock. Within that, we see pins, right? There are red key pins. These are the pins that touch the key if we were to insert it into the lock. And then there are blue driver pins above that. And then above those, there are the springs sitting in the housing of the lock. And so the idea here, of course, is you need all of those blue pins to be in a line. You need a straight line between the blue and the red. So you have a shear line that is right at the top of that plug. So the key pins will stay in the plug as you turn, and the driver pins will be up in the housing. So what does that look like? If you insert the proper key, again, we have a nice alignment there between blue and red. You can see that nice clean shear line across. The lock is able to turn. Of course, if you had a key in there that was, one of the cuts was too high or too low, either the red or blue parts of that position would block the turning of the key, and the lock wouldn't open. So let's talk a little bit about master keying. So how does master keying work, right? The idea of having multiple keys that can open a single lock, of having a key that can open multiple locks in your environment. And we'll talk a little bit about the hierarchy there, but just at a really basic level, it works by inserting these additional pins. And so in this case, you can see there's additional pins here in green. And so now the pin stacks that have those green pins could open if it was if the shear line was set there between the blue and the green pin, or the green and the red pin. Let's take a look at that. So here you can see, right, the lock is going to open with this key because we have that nice shear line across, in this case, between blue and green on those second and fifth pins. It would also work if that key was cut a notch higher, right, and you were between the green and the red, just like this. So in this case, what originally was a number 8 pin is replaced by a 2 and a 6, and so a key that's cut with either 8 or 6 will open this lock in that position. So if we do that across most or all of the pin stacks, we can start to see that there would be a large variety of keys that would work in this one given lock. And so in this case, we have keys from Alice, and we have say a janitor's key, right, or a maintenance guy's key with the paint splotched on it. And maybe Alice's key only opens Alice's office, but the maintenance guy's key will open all the offices in a given building. And so here you can see the maintenance key is operating with all of those green pins lifted, whereas Alice's is not, right? So again, multiple keys here. You can see the coding at the bottom. Alice is 36235. Maintenance guy is 34231. Both keys are going to work in this lock. So that's the basic premise of how this works. And of course, the lock, there's no intelligence in these locks. These aren't electronic locks or anything. The lock doesn't know or care if it's operating with one pin at the green-red boundary and one pin at the blue-green boundary. As long as you have any combination where you have a nice shear line that's cut across, you're good to go. Okay, there we go. So how does this look in a larger organization? You probably don't just have a few offices with one maintenance guy or one security guard who has access to 5 offices or something. If you have a large campus of buildings, you're going to have a series of keys. And so you're going to have a number of operator keys or change keys as they're called, and then you might have a master key above those. So you could imagine a scenario where you have a team of a dozen people and they all have their own offices, but then they have a boss, and that boss maybe has permission based on the company's policies to go into their offices. So their boss's key might work in his office and all of his employees' offices, but not the employees of a different team. And then maybe his manager or maybe the janitor or something has one level up from that, and that janitor can go in all the offices in a given building, but not the offices in the R&D building next door, right? And so there you go from a master key to a grand master key. And then maybe security, for life safety reasons, needs to be able to get in anyone's office, and so they have the great grand master key, right, in this hierarchy. So this is how master key systems are generally built for large organizations, and you can have thousands and thousands of keys in a very large system like this. And so again, let's just look at what the bidding, so the cuts, the specific cuts on the keys would look like for one of these systems. This is just a quick example, but just to illustrate kind of how that might look, right? So here at the top, you have the Grand Master key. This key is going to open all the locks in the system. And then maybe you have a Master B that would open most of the locks in, say, all the locks in one building, but not all the locks in a different building. And then you have a Submaster, which is like that manager scenario we were talking about, which can open some locks. And then you have operator keys. And so the way they actually define these keys and build out the system, you can see the operator key, so let's say BA18 opens Office 18 or something, is completely different from the Grand Master key, right? If you look at the numbers, none of them match up. 8301836, the operator key 6783250, none of those numbers are in common for any of those positions on the key. But then if we look at the keys in between, the way that works is they share some positions on the key. So the Submaster key has a few of the master pin cuts in it, so it can open all those offices with those numbers, but it can't open the rest. And so it kind of moves like that. And you can see the 2 operators can share some positions, but they're opening different offices, right? So that's how overall how master keying works. So let's start talking about some attacks, and we've talked about how these systems are built. And so most of these attacks assume some level of insider access. That's the way I run a lot of my assessments, is worrying about either malicious insiders or someone who can get kind of a foothold into the environment, but maybe doesn't have the full rights to the environment. And so I'm concerned about people being able to escalate their privilege, right? If I have an office key to my office, how do I use that to leverage to get into someone else's office that I don't have a key for? So the first attack is picking, of course. I'm into lock sport. I like picking locks, so why wouldn't that be my first go-to? That's a reasonable thing to assume. You can see here, this is a Best Cormax lock on the right-hand side. This is a pretty common kind of lock used in a lot of institutions. It's got a lot of different pin stacks. It can be master keyed heavily. You can have, again, thousands and thousands of keys in a system using these locks. So that's great. And again, these are used, they're very popular in businesses because it's the SFIC format. So the small format interchangeable core. It's that figure 8 kind of snowbandy looking lock. The idea here is that when maintenance or your locksmith wants to come in and rekey the locks or replace a lock, there's actually a special key that will turn the lock just a little bit. And what that's doing is on the back side, there's a special feature of these locks that holds the lock in place. And so if you're using the right key, it's actually a separate shear line. And when you turn it, you can remove the entire core of the lock instead of just the lock. And so with this special key, you can very quickly come in and remove a core and put in a new core. And there you've effectively rekeyed the lock in a matter of seconds. You can then take the core back to your van or your shop and dump the pins and actually repin the lock itself. But the time on site in front of the lock doing the work is greatly reduced, which is great for a lot of businesses to make these quick changes. So this kind of format is very popular, but picking it isn't so easy. Again, it has those 2 shear lines. It has the operating shear line and this control shear line. And because of that, when you're trying to pick it, you can easily get some pins set on one shear line and some pins set on another, and the lock's not going to open if that happens. There are some special tools that let you try to pick just to the control shear line. You can look up papers from Matt Blaze. The tools are sold by several companies. I know Peterson makes some. You can look up how those work. They're a little hit and miss. Sometimes they're great. Sometimes they're not so great. Additionally, these locks often have 6 or even 7 pins instead of just like the 5 you're probably used to for home locks, or 4 you might see in some lower end padlocks. So they're definitely more of a challenge. Yeah, so picking, well, great. If I was on a red team operation, I don't want to sit in front of a door for 20 minutes trying to pick a lock that I might get stuck trying to open. So in practice, in doing an engagement or something, picking is out. It's fun to do at home, not so fun to do when you're actually trying to break in somewhere. So if we're taking picking off the table, what other attacks do we have? We have quite a few attacks we can do, so I'll talk through those. The first is a social engineering and co-conspirator attack. And this attack works because according to the spec for most of these master key systems, no cut on an operator key could collide with the grandmaster bidding. So again, let's just look at this example. So again, the operator BA18 or the operator BA23, none of these cuts collide with the grandmaster. They share some of the master and submaster, again, because those keys are less permissive and only working in certain buildings or certain areas of buildings. But the grandmaster is completely unique and distinct from the operating keys. So given that, if we know that there can be no collisions between those two, it means if I look at my key, I know that my key, right, if I have that 18 key, I know that 6 in the first position is not the grandmaster cut because I know my key isn't special, it's not privileged. And so the master key, the grandmaster for that can't be 6. I know for the next position that the grandmaster can't be 7. I know for the next position it can't be 8. I know for the next it can't be 3, right? So on. So I've now eliminated one possible position out of that key. And depending on how many cuts your key system has, you've now reduced it by, I don't know, 12% or maybe even more, maybe 15 or 20 or 25%, right? So that means if I look at enough keys, I can eliminate more positions. And eventually, if I see enough keys, I'll have seen every possible cut except for the cut that's the master, if I'm just looking at standard operator keys. So if I have enough co-conspirators, I can then figure out what the master key is. The interesting thing about this is there's also a concept in locksmithing called MAX, which is the maximum adjacent cut specifications. The idea here is if you have a key that looked really like a high-low kind of key, you could potentially get that key stuck in the lock, or you could break the key more easily. It makes it too weak. So you really don't want to make keys that have this really big sawtooth pattern. And so some manufacturers will say the cut next to another cut can't be more than this far off. Or, if it's the first cut on a key, it can't be too deep. There's a lot of different specifications, just depending on the keying system, depending on the cuts, the strength of the key, all those things that actually eliminate more positions. And so you don't even need to see every single position. You can probably just see some, and then you can just process of elimination, knowing the keying system, eliminate a few other positions straight away. And so knowing that, we can reduce the key space even further. And I wanted to figure out how many keys I'd actually need to see for a given system to figure this out. The problem is it's a lot of math involved to do this. And so I asked a very smart math professor friend of mine, and he said, well, you're good at computer science, so why don't you just write a simulator that will figure this out for you and just run 1,000 simulations. That'll give you the answer anyway. I'm like, oh, that's a great idea. So I did. You can find the source code up there online if you want to pull it down and play with it. So this does support some basic max functions, probably not all the different things that all the different manufacturers support, but at least gives you a basic idea. And so the idea here is the program will randomly generate a master key that's valid for the system, and then it'll start generating valid user keys for that system randomly. And then it'll tell you once it's figured out how many keys it needed to see before it had eliminated all the positions. And so here in the screenshot, you can see the last simulation that ran. After looking at 17 keys, it had figured out what the master key was. And before that, it had done 19 keys. And so you can just tell this program to run 1,000 times, 10,000 times, and it'll give you the average, the minimum, the maximum number of keys it had to see. And so in this particular system we were looking at, the least keys it ever saw before it had the master was 12, the most was 65, which is kind of a pretty bad case. Average was 25. And this is a keying system that has a lot of different pin cuts. You can see there's 0s and 8s in there, so this is a lot of different depths, so not a very friendly system for this kind of attack. Other systems have far fewer cuts or positions available per pin, and so they'll go a lot faster. And again, this keying system has 6 different pin positions. You can see there's 6 different columns there. Some might only have 5, and so that would again reduce your search space even further. And that's not even to say anything of the fact that maybe we're not even trying to get Grandmaster, right? If we only care about getting a submaster key, maybe I can just figure out that everyone in my office has the first two cuts the same, and now we've reduced the search space from 6 pins to 4. So you actually need to see a lot fewer keys than you might imagine to do this attack. So how would you ever even see that many keys, right? Like even just seeing 12 keys within your company might be a lot for you. Well, you can think of different ways that you might be able to pull this off. So one is you could land a semi-privileged role. And so think about who in your organization sees a lot of keys, and are those people necessarily like super trusted people, right? Are they people who've been background checked and gone through a bunch of different security things, or are they maybe people who don't have like the most security sensitive job in the company? Who gives out your keys to new employees, right? Maybe that's HR, maybe it's the receptionist, maybe it's the hiring manager. Who handles when you move offices, right? You have to turn in keys, get new keys, or get your locks rekeyed. Who's involved in that process? Who comes out when you've broken a lock and does a replacement there? Are you contracting that work out? Are you doing it in-house? Who's seeing all those keys? Also, who handles keys when someone leaves your company? Are they turning their key into the receptionist, their manager, HR, security, who, right? So whoever is in those positions, they have the opportunity to see a bunch of keys and potentially pull off this attack. But you don't even need to be in one of those jobs. I've actually successfully done this just talking to people, right? You can think of different things that maybe don't make a lot of sense, but people don't maybe think if you seem trustworthy that you're there to do anything malicious. So it could be something like, yeah, I left my keys at home. I think our keys are all the same for all offices. Can I try yours in my door? And you walk away with their key, you come back a minute later and say, oh yeah, sorry, I was wrong, it didn't work. Do that to 10 people, and if you are writing down what their cuts are on their key using a tool like that key gauge I showed on the earlier slide, you've figured it out. Other things that work is, hey, can I just see your key? Like, do we have the same marking? Do you have this weird letter stamped on your key? Stuff like that. Or, hey, you look super busy, right? Like you're carrying in a bunch of stuff from your car, you're setting up for the holiday party or something. Let me help you with that. Here, give me your keys. I'll go open the door for you. And, you can snap a picture of their key and figure it out that way. You also don't necessarily have to be close to the keys to see them. You don't have to hold them in your hand. There was a good study done at UC San Diego. I think there's probably been a few other versions of the study that have happened, but you can see here that from far away with a good camera, this team was able to take pictures of keys sitting on this table out in the open and figure out what those cuts on those keys actually were just from the photograph. And this was from 2008, so presumably cameras are even better now. There's better software for doing this, so this kind of attack just becomes more and more possible. So yeah, if there's a common area outside, or people are maybe set their keys down when they go to lunch or things like that, just walking through a building, you can probably snap photos of people's keys as they're using them, things like that. Another attack is kind of related to the last one. Who carries around privileged keys? Probably your security guards, maybe your janitors. Are those keys always hidden, or do they wear them on their belt like this? This is a photo I snapped, not of someone from my company, but just when I was out at a coffee shop, right? You see this all the time, people wearing keys on their belt. If you get a high enough resolution photo, you can decode what the keys are. And if that's someone who's in a privileged position, then now you know what the key is for that role. All right, so another attack is one that me and a friend of mine have dubbed the fill and file attack. And so again, if we revisit that concept of no collisions between the operator key and the grandmaster, that means if you think about it, if I have access to just my lock in my office and I want the master key for my building, I know that there are potentially multiple cut depths that will open for every position on my key for all those master pins, right? So if I take a key that's cut exactly like mine, except one pin is cut to a 0, like the highest possible depth, right? Very little material taken off the key. And I try that in the lock. So it's got, if it's a 5-pin lock. 4 of the pins are cut to the same exact position as my key, and I have just one set to 0. I try that out. Does it work? Does it open the lock? If it does, and my key didn't have a 0 in that position, now I know that, okay, 0 plus whatever my key was are the possible cuts that work in that lock, so 0 must be that master keying position in this lock. Odds are 0 is not the cut, right? So I try it, the key doesn't open the lock, I take it out, okay, too bad. That's fine. I now take that 0 position and I take that key and I recut it down to a 1. I can just do this with a file. This is like impressioning, if you've ever seen that. Just reduce that position from 0 down to 1, try it again. Does it work at 1? No? Okay, try it at 2, try it at 3. Eventually I'll find another position within that lock where that key works. And now I know a cut in the lock that isn't my cut that works. This is most likely going to be the janitorial or the grandmaster cut. Okay, so now that I've taken this one key down from 0 to whatever depth I needed to figure that out, I now go get a second key and I cut that one just like my key, but instead of the first position on the key leaving at 0, I'm now leaving the second position at 0 and cutting the first position down to a working position I know. Repeat this process. And so I do this for every position in the lock, and eventually now I've decoded and figured out exactly what I need and can go now cut a master key. So to do this, I need as many blanks as positions in the key, right? Because I'm trying a new position on each key and eventually running out of the positions and making that blank not usable. And so if it's a 5-pin lock, I need 5 keys. If it's 6, I need 6. If it's 7, I need 7. And then I probably need one more blank after that to actually make the grandmaster key that I want. So not a ton of blanks, but still some. I need access to them, right? But what if I can't get those blanks? What if my company is using a secure keyway that you can't buy these blanks anywhere? I can't order them online. You need a special authorization form to buy these keys. This is not uncommon, right? Higher security locks tend to have restricted key blanks. You can't just go out and get them. Well, that's interesting, but I already have access to this one key that's on that keyway. What if I can use that? What if I could make my key work and try it in those positions? That's cool, but again, my key already has these cuts on them, and so some of them are probably too deep to actually try this out, right? If I have a key that already has a cut depth of 7 on it, I can't try positions 6, 5, 4, 3, 2, 1, 0 on that spot. So what I do, what if we use solder? So how does that look? Well, we take our normal operator key that gets us into our office. And I've blurred this out so you don't see what actually cuts it had, but you'll get the idea. And we can get some flux to make sure the solder is good and stuck to the key because we don't want it coming off in the lock. And we'll apply some flux to the key and get some solder. Make sure you're using lead-free, be nice and RoHS compliant and nice and safe. And start filling up a position on the key. So you get a nice big blob of solder there. Now that's back to a 0 cut from where it was before, but that's obviously not going to fit in a lock. That's an ugly blob of solder. So you can trim it down. Luckily, solder is pretty malleable, so something like a razor blade is perfectly good. And then once you've cleaned that up, you need to cut it to exactly the right depth that you're trying to go for. So you can use either a nice key machine, or in this case, you can get a tool like the Lishi key punch, where you just basically have a pair of pliers that's just got a little gauge on it and can cut down your key. And after that, you've got a nice clean cut. You can see here, this is looks really good, right? It's nice and flush. It'll definitely fit in the lock. That'll work. That'll do what we need. All right, so you do that again, filling up with solder one position at a time, testing it out, trimming it down, and eventually you get this working key. That's awesome. Using the solder, it actually looks really good, like you saw there. It looks almost as good as an impression key. We can talk about impressioning in a minute. You probably don't want to use this key all the time though, right? This key has solder on it. That solder could eventually break off, come loose, get gunked up in the lock. Not so great. So if you are going to try a key like this, make sure you're bringing a key extractor, right? So that's used to remove broken keys from locks. You might need it in this case. This can't be used to derive the control key. So we talked earlier about SFICs, where you have a control key that can remove the lock from the core versus actually operating and opening and closing the door. The control key is a different shear line, so you're not interacting with that shear line when you're testing this, and so you're never going to figure out what that control key is. But let's say you actually want to remove locks and take them away. How can you get a control key? Well, one thing you can do is actually steal a lock, right? The idea here is we want to get the core, but a lot of times locks get thrown away, right? If a building is being upgraded, what happens to all the doors? And are the locks that are being installed after the doors are thrown away the same system? They might well be. So if you can find doors scheduled for demolition, you just walk up to the saw and steal that lock off the door, take it back to your, your place of work, your garage, your workshop, and manage to get the lock out of it. You can measure the pins, and once you measure the pins, you know what the cuts are supposed to be for that key. So once you've stolen a lock off a door, you actually want to be able to get to the pins and not destroy them, because the goal is to measure them. So we actually did this. I'm going to try to play this. I don't know if the video is going to come through super well on the WebEx. I apologize if not. So here you can see with just a drill press, with the lock housing in a vise, we're just taking material off the side of the lock. We don't want to drill down the center, like you might see a locksmith drilling out a lock, because that will destroy the pins. So we're just going for the brass body material that we don't care about. And once we've done that, we've weakened the body enough, we can just pull the housing apart. And it might be stuck in there a little bit, so grab your pliers again, vice grips. And there you go. Okay. So again, you don't want to follow the manufacturer's directions on how to drill out locks if you're trying this attack, because you can see here where they're saying where you should drill. You can see that that drill is going to go right through those pins and totally destroy them. You won't be able to figure out what they are afterwards. You definitely won't be able to make a key out of it. Now there are tools to dump out the pins once you have that lock out of the body. Like here you can see this little annex from Lab. It costs $140. That seems like a lot for just dumping pins out of a lock, but we do want to keep the pins in order. We want to be able to measure them and make sure we're not getting them confused or mixed up. Otherwise, what's the point doing it? So we need a nice way to dump out pins and keep them well sorted without spending $140. So what do? We go back to our drill press and we get two pieces of plexiglass and tape them together with some painter's tape and apply some water so we don't melt the plexi and get it all stuck together. And there you go. 2 scrap pieces of plastic that cost us nothing, plus 10 minutes on a drill press, and you've got your own annex. Doesn't work quite as well as the professional one, but definitely effective enough for pulling this off. And so here on the right, you can see I've blurred out the pins so you don't see what measurements this particular lock was using, but you can see here, you can very clearly see the pins through the plexiglass. You can pull them out individually and measure them with calipers, that kind of thing. So worked really well. Yep, so then you just want to measure the pins. This will tell you the different possible keys that would work in this lock, right? Basically the same thing we were trying to deduce, but now you're just looking at it visually right in front of you. So get out some paper and build a nice graph of all the different pins, and you can figure out what all the different possible keys are that are going to work in this lock. Okay, so now that you know the depths of the pins, you still need to get a key, right? And so how are you going to do that? Well, again, you could do the fill and file. You don't necessarily need to fill the key all the way up again and test all those positions. Now you know what they are. You can just put solder to the right amount, trim it and cut it, and you've got a working key. Again, that's if you've got a restricted keyway. Otherwise, you can probably just go buy a blank and get a key made. If you don't have a key or you don't want to mess with your key and put solder on it, and you can't go buy a blank, what other options do you have? Well, you could 3D print a key. There's been a lot of articles. Here's one from Wired from 2014 saying how you can actually print keys out of plastic and they can work. Another interesting thing here is you can see a lot of different aspects of that key, right? The key has a very distinctive shape. There's a lot of different grooves and notches in it. What if you thin out those, right? The key will still fit in the lock. It'll probably still work. Eventually you can make it too thin or it'll break. That's no good. But if you're looking at a system that has a bunch of different keyways, potentially you can make this key more permissive, right? You can make it fit into more than one lock. And so if you're using the same pinning for your grandmaster across multiple keyways, now you've got a lock that actually will satisfy all those different locks as well. So this is what some 3D printed keys look like. Obviously, there are even way better ones. These I think look like they're FDM printed. You could print them on an SLA printer where you get a little bit higher resolution, or you could call out to a printing service like Shapeways and print them in different materials, even metal, and get yourself a good working key. Another option is if you have some brass, you could go and mill them yourself. If you want to model the keyway, there's different software packages that let you do this. Some genius hacker types have released tools. Decoder released a tool, I believe, that will let you do this to model those keyways onto the brass. You're actually cutting key blanks yourself right on the CNC mill. Pretty cool. Or if you have a lot of money to burn, there are some companies that make specially designed mills that are meant to do this, right? The easy entry is one of these where it will basically scan and measure your current key and then go generate blanks right off of that key. So pretty cool, pretty spendy though. And finally, I want to talk about one extra attack. So this is a little bit outside the scope of my talk, but if you know anything about impressioning, Joost Weyers is a very good impressioner. He's a world champion impressioner. He's won the Dutch Open many times. He's won some of the German competitions. Brilliant guy, super nice. He actually can impression a lock in competition often in under a couple of minutes, which is just incredible, right? Impressioning, if you don't know, is the process of taking a key, like a key blank, sticking it in a lock, jiggling it around, pulling it out, looking at it under magnification, and looking for scratches, filing those scratches down to the next cut depth, putting the key back in the lock, trying it again, pulling it out, looking for scratches, filing those down. Eventually, the lock will basically tell you what its pins are based on how it's marking those keys. So again, very impressive. The cool thing about this attack is actually getting those scratches on the key is just a matter of putting the key in the lock and jiggling it around a bit. And so if you were to try this attack yourself, if you were walking up to a door, right, you stick in a key, you try it out, you walk away, none of the filing has to be done at the door, so it's not super obvious. It can be done pretty covertly. Well, he came up with this really cool talk from OSSECCon last year about how you can use this method to get master keys. And so it does rely on having access to a blank and having access to several doors in the system, but as long as you have access to those things, you can actually figure out what a master key is using impressioning to. So really cool talk. I encourage you to go check that out. It's up on YouTube if you want to see. Just search for OSSECCon master keying impressioning and you'll get it. And the link there is down at the bottom as well. All right, well, I wouldn't be a red teamer if I didn't also talk about mitigations, right? It's my job not just to find vulnerabilities, but to teach people how to not be vulnerable to them. So what are some ways you can protect yourself and your company against these kinds of attacks? First of all, you can use locks with restricted keys. Now, we've talked a lot about bypassing keyway restrictions through 3D printing and things like that. But as you saw, there's a lot of work that goes into making this work if you can't get blanks. If you can get blanks, it's way easier. You can just do the impressioning attack. You can do several of the other attacks I talked about. It just speeds things up greatly. So using restricted keyway, first and foremost, is definitely going to make your attacker have to put way more effort into getting this to work. Next, you can limit the number of people who can see multiple keys. Again, you want to restrict that group so you can't do the social engineering co-conspirator attack where someone's just getting all these keys. And so you want to make sure you're trusting whoever's handing out keys, taking in keys, all that kind of work. You can remind users not to display their keys, right? If I can take a picture of a security guard with a key on their belt, I don't have to do all this math and all these things to figure out what the key looks like. I now know what the key looks like. I just have to go cut one. So especially people who have very privileged keys should make sure they're not on display. But again, you don't want that co-conspirator style attack. So just make sure no one is showing their key is best practice. Make that a company policy. You can consider hybrid key systems. So we've only talked about physical keys here. Of course, there's a lot of electronic style keys, and there are some hybrid keys, right, where there's a electronic component and a physical component. If you're using one of those, it doesn't matter if you figured out what the physical part of the key is, you still have to figure out how to bypass that additional electronic component. That's maybe RFID or some other electronic system. And finally, use defense in depth, right? And so We see this in computer security all the time. You don't want to rely on just one security control to protect your entire organization. So if you're just relying on those locks and nothing else, you might be in trouble. But if you have locks, you have multiple layers of locks, you have cameras, you have security on patrol, all these different things, you're not relying on one thing that can be compromised, allowing you to compromise the entire system. You have to get past multiple levels of security. And so defense in depth is always the best bet. I want to thank some folks. Each of them have helped me in some way or another in this talk, either by doing previous research on the topics or helping me specifically do some of these attacks, or just giving me some ideas or brainstorming with me. So thank you all. And finally, some references if you're interested in this kind of thing. These are some of the materials I used in this talk, and also some other good research on similar things. So here's that list. That's all I had. Thank you so much. Appreciate you having me.
Thank you very much for that, Matt. So we're just going to hold you here for another couple of minutes here while we give a chance for the audience to put in any questions, either in the questions tool on the upper right-hand side of their screen or in the Discord channel. And so we'll just give them a minute to type that in and see if they have any questions for you about this.
Sure.
In the meantime, thank you so much for coming and presenting. I've used the solder before to fix keys, but never to try to attack master key systems. I didn't know about the using flux first. So mine was very, very weak. Had to keep rebuilding it.
Yeah, it also helps to clean the key first. You know, if it's been in your pocket for years and all that, might be a little dirty. You know, have oil on it and stuff. So cleaning it off first will help too. So
yeah.